Hello everyone. Now the mathematical problem that we look into today is one of the questions that students find it hard to answer during SPM 2019. This mathematical problem is based on SPM 2019 paper 2. Let's have a quick look on the information that we know of. Diagram 4 shows a dart target board in a dart game. So it's about dart game booth in a fun fair. The booth offered 3 darts per game, or in a game you can only have 3 darts to try out. The customer have to pay 5 ringgit for a game. A toy bear will be given to customer who are able to hit the bullseye. Do you know what is a bullseye? No, this in the middle. Bullseye for the 3 darts throw in a game. Meanings in a game, there are 3 throws you can have in a game, and you need to make sure you have all of them hit the bullseye in order to get a bear. Okay, in a row, meaning bullseye in a game. Then you can get a bear. By average, Pop is a dart player. By average, he hits the bullseye 7 times out of 10 darts thrown. Meaning, what does it mean? This is the success rate for the probability of what? 7 over 10 is the success rate of the probability of Pop successfully hitting the bullseye in one time. Right, one time. Okay, now we go on. Number A, Pop will play the game if he has at least 90% chance to win for at least 1 toy bear by spending 30 ringgit Malaysia. So it's a bit confusing here, right? At least 90% chance to win at least 1 toy bear by spending 30 ringgit. It's not the usual question that we deal with in probability distributions, right? It's not the usual questions, but it's fine. Let's get it done step by step. By spending 30 ringgit, this is something to do with 5 ringgit, am I right? So if you have 30 ringgit, 5 ringgit per game. So how many games can Bob try? That will be 6 games in total, right? 6 games in total. And this is the success rate of getting the dart hitting the bullseye. Now what we want now is the success rate of getting a toy bear. How do we get a toy bear? In order to get a toy bear, he needs to make sure he has bullseye consecutively for 3 times, right? Meaning to say if 7 over 10 is the success rate of getting a bullseye, 3 times in a row, that will be power 3. Right? In order to win to get a toy bear, you need to have 0.7 power 3. Why power 3? 3 times in a row. Success rate. Success. Bullseye. And you have how many? Say 0.343. Am I right? Let me check and see. Yes, 0.343. This is the success rate of getting a toy bear. Different, You have to be able to differentiate between the red color and the green color underlying P. The success rate is different, regards in different things. So this is the success rates of getting a toy bear. He has 6 games, meaning we know that the total trials n equals to 6 in order for him to try out. We need to see whether we have 90% or not. At least 90%. If let's say the answer, the probability is more than 90%, then Bob should try out because there's more than 90%. If let's say the probability that we get is less than 90, then he shouldn't try out because he has less than 90%. So we need to find the probability in this case. Now how do we find? This is the keywords. To win at least 1 toy bear, meaning the success at least 1, the probability of x more than equal 1. It can be 1, at least 1. It can be 2. X can be 1 toy bear, 2 toy bear, 3 until what? Maximum the number of bear he can get 6, right? Until 6. Why? Because you only have 6 games. So it's either 1, 2, 3, 4, 5, 6. You can list out the formula in this case, but I would rather go for shortcuts. I'll use 1 minus the impossible case. If he will have at least 1, the impossible case will be he has what? The impossible case? He has none of the toy bear. No toy bear at all. So no toy bear, that will be 6C0, 6, right? N equals to 6. Because he has no toy bear, success rates 0, and the failure is Q. Q is 1 minus P. So you have 1 minus 3, 3, 4, 3, you should have 7, 5, 6. Is it? Am I right? Better I check. Yes, 0.657. So 0.657 power 6. And the answer that we have, that will be the probability of Pop getting at least 1 toy bear. We see whether it's more than 90 or less than 90, then we can decide for him. 0.657 power 6 1 minus, so we should have 0.4 significant figure 9196. Now what does it mean by 0.9196? That would means it is 91.96%. He has 91.96% to get at least 1 toy bear out of the 6 games. So should he play the game? At least 90. Yes, he should play the game. Okay, that is the answer A. That is the answer A. Okay, we go on. Okay, we look at B. What is the minimum number of game that Pop needed that he can get 4 toy bear? Okay, so to get 4 toy bear, minimum number, I will associate it with NP, min. Yep. Because you want to know the minimum number, I can look for the average number to get 4 toy bear. Average means min. So min, we have NP, right? NP to get 4 toy bear. Let's say we have NP equals to 4. No, to get more 4 minimum. NP more than 4. And N is what? Do we know the N? No, this is what we need to look for. Do we know the P? In order to get 1 bear, what is the success rate? In order to get 1 bear, do we take 0.7 or do we take 0.343? Which one? To get 1 bear. 343, right? 0.7 is to get 1 dot in the bullseye. So we have 0.343 more than 4. And N equals to 4 divided by 0.434. We have N greater than 11.664 significant figure. So N must be more than 11.66. Do we take 11.66? Do we take 11 or do we take 12? Minimum number? Minimum number, it should be 12 games. Okay, it cannot be 11 games. If 11 games that is not, you do not have enough, you need to have at least 11.66 games to get 4 toy bear. So if you put 11, it's not enough. You put 12, that is the minimum number. Meaning you actually put more than 12, right? 13, 1400, so on and so forth. But minimum 12 game in order to get 4 bear. Alright. Thank you.